Hi and welcome. We finally reached the last internal piece of the belt sander. There's a couple more pieces to do outside, and I saved the most complicated for last, of course. And this is the top part of the tilt tensioning mechanism. So this whole piece goes up and down to tension the belt, and this one side goes up and down to allow belt centering for tilt. And I'm still not convinced this is going to be stiff enough. It also allows more degrees of freedom than I need. It really only needs to move in two like this, but this will also move in the other plane right here, which isn't necessary. Hopefully it's all going to be stiff enough to be fine. On this side there's this metal plate here, which I haven't drilled through this yet, but we're going to drill through this guy, and there'll be a pin through going through a little slot over here that'll allow this mechanism to tilt like this, the roller to tilt. We've got bushings that it rides on, the back parts of the T, and the threaded part here that you will see me make shortly. There's an ACME threaded nut. I had one already that I bought from a MasterCar, but it wasn't long enough, so I decided to go with this one instead. This is the piece of stock for that mechanism. I've got a ton of material that's got to come off it. There's going to be a slot put inside this side where this will reside, because I wanted to make it out of steel instead of aluminum. And on this side, we're going to notch out a huge section of this and then drill and ream and bore. Probably just bore, because I don't think I have any reamers big enough. I might. I got to check that. Anyways, here is the ACME threaded nut that I got from MasterCar. And I've already pre-cut a piece of brass, and I'm going to cut my own. I've taken out the normal 60-degree threading insert and put in an ACME. It's a 16 IR10 ACME 10 thread per inch insert in here, and we're going to try and cut these threads. All right, so I'm set up and ready to go, and I had a ACME screw pitch gauge, which I thought was the same as the ACME normal ACME thread pitches, but looking at these, there's no 10 TPI in here. There's 2P, 3P, 4P, etc. And they don't match up to the 10 TPI sample I've got. So I'm gonna have to wing this to make sure that the 10 is correct. I do have a sample piece of shaft that will let me verify that it's working, but you know, that's going to be later on. The 10 thread per inch setting on my lathe, I'm just going to have to trust that I got it right. The total thread pitch depth is 50 thousandths plus an allowance, and the allowance is another 10 thousandths over that. I got to remember that this is radial I'm talking about, but my DRO measures in diametral. So we're going to do a 10 thousandths a side pass. That may be a bit aggressive. Let's try 5 thousandths per side pass. And on my gauge down here, I've got to take any non-number. This is pretty fast that I've got this at. It might be a bit fast. I am going straight in with this. Well, that seemed to work okay. Let's try another 10. Still really tight. So the 60 should have been the halfway mark, and now we should be getting closer. I'm at 90, and yeah, now it's threading in and it's snug. So I'm gonna go to 100, which is the exact thread depth, but without the allowance. So that may not be adequate. We may have to go a little bit further than that, but I'd like to make these fairly tight threads. So let's get it here at 100. And and bring it out far enough to make up for potential mistakes. And we'll do a spring pass. Fortunately, brass is so easy cutting, you can get away with this. If this was steel, this may not be so easy. So let's go here, go back to exactly 100. And this is a direct plunge cut. We're not using the compound at all. Aha. Yeah, with this depth, we are removing excess material, so I will continue doing spring cuts until I don't get any extra material off. Okay, let's give it a test. So this is 100 thousandths depth, which is exactly what an ACME 10 thread per inch thread is, and it starts, but it's too tight. So let's walk it up 5 thousandths at a time. So we'll do 105. I'm expecting to be around 120, but maybe I can get a snug enough fit. Ooh, that's a nice fit right there. But it gets tight. Okay. Let's give it a shot again. So we're at 115 thousandths total depth right now. And we are through. All right, so here we are. A very nice fit. And the nut that I bought from McMaster was 1 inch. This one's 1.5 inches, which just gives me more support in the X and Y plane rotation in the tensioning piece. So there's, hopefully you can see in the threads, they're kind of pretty. Did a very nice job. I'm very impressed. I did take the easy way out. I mean, I could have done a harder material, a more difficult material like steel, but I chose to do brass because for this project, it's more than adequate. So anyways, moving on. I'm going to start with this piece first because it's the simplest. I like to go from simplest to hardest so I can really focus when I get to the hardest pieces. And my mind doesn't think about all the other pieces I have to make. It's just sort of how my mind works. So this guy here, this is a scale drawing. This guy here is going to get a slot right over here and a couple screw holes to attach it to this piece up here on this side going up this way, and we'll also slot this side. That gives it control of 2 degrees of freedom there. The screws will hold the rest, and there shouldn't be an absolute ton of force on this, but anyways, I tend to overbuild everything. That's just how I roll. So on the side here, we're going to drill and ream for a pin, and then we're going to drill and tap for a set screw that'll hold that pin in case I need to replace it. This could be an ugly experiment. I'm trying my freehand drill grinding skills, which probably are not great. I've been working on it, but still have a long way to go. Guys like Tom really make it look easy, don't they? One reason it looks so smooth, because it was hot rolled steel. One reason it looks so smooth is because I decided to try my hand at surface grinding it just for the heck of it. Interestingly enough, now that it's surface ground and flat, when I tap this down in either side over the parallels, it locks immediately, no struggle at all, which I guess you could sort of expect. The next 2 holes will be mounting. After this one, we'll be mounting holes. Okay, now the original 3 holes here. that I'm ultimately going to go to 1/2 inch end mill with. I'm going to start with a 3/8 inch end mill, and I'm going to use it in the drill chuck. Yes, I know that's not a normally prescribed behavior because drill chuck jaws are not designed for that much force, but we're actually drilling with it, so I think it should be okay. Actually, I'll just get a 3/8 inch drill bit. That'll make everyone happy, right? I tried a drill bit, but because one side of the hole is open, it wasn't going great. I think the drill bit was wobbling. So I'm going to try 0.375 with an end mill, which shouldn't care very much. Yeah, that's much better. Evidence of the drill bit wobbles right here. I should have shown this on camera. I didn't even think of it. I just decided to take my drill chuck back to the exact same spot where I drilled, where I said I thought it probably was moving this direction because one side of the hole was open and drill bits don't like asymmetrical cutting. And sure, lo and behold, see all these cuttings here? That's by taking an end mill down the exact same hole. So the drill bit deflected this direction, this way. So good to know, right? Okay, I've switched to a collet, and we've got a 1/2 inch end mill in here. We're doing the center hole first. Traverse. And there's my slot. Looks like it's pretty nice. So in case you're wondering, here's my thoughts on using a vacuum cleaner versus air. So air is faster. You can just grab the air thing and blow the stuff out. But then you have to go clean it up again later. So you're actually doing two operations to remove. First, you're trying to get the chips out of the way, and then you're gonna have to go clean them up. This way, it cleans them up and gets them out of the way all at one time. All right, so I need to deburr this guy, and then we're gonna flip it on its side, and we're gonna drill and ream for a 3/16 pin that goes all the way through down the center here. And then we're gonna drill and tap for a set screw that goes behind it to hold it in place. I used my Tom Lipton inspired idea to preset my 0 here, and when I flipped this over I just double checked, and sure enough 0, is right over here, right on the money, within a couple tenths. That's pretty awesome. So we are good to go. I don't have to, I was just verifying, but I don't have to do anything. All right, we are there. Now we just need to ream the same hole, but first I need to clear the chips. Which means I gotta move this, and normally I'd have to re-indicate, but fortunately I've got my 0 set. Oh, look at those chips in there. Because we don't want these chips interfering with the reamer. And it is a blind hole. I've decided not to make this a blind hole after all, so I flipped the part over 180, and I'm going to drill a hole that's just one size over 1/8, so that if I ever need to knock this pin out, I can, because if it's a blind hole, it'll be kind of difficult to get out. There we go. That should make knocking the pin out easy, but it'll still support the pin on the other side. So now we can take this guy out. Gotta make sure this is nice and clean in here. Okay, now we're gonna ream this guy. Okay, we're in the center section. We're not shooting for an interference fit here, by the way. We're shooting for a slip fit. So I've got to once again clear chips out of there. Oh, that's kind of a sloppy fit. Yeah, that reamer bouncing around, definitely not good. Yeah, because this thing falls in on its own. All right, well, the set screw fortunately will push this thing into place. I've made the other end conical by putting it in my D-bit grinder and grinding the end. So I will push it into a smaller diameter. This should hold nice and tight. Still, I'm a little disappointed. I usually get better results out of reaming. I tried to do it at higher RPM this time, and that may have been part of the problem. This was at 450 RPM. Also, this reamer is not new. It is one I bought in a set used, so I have no idea how good it is. I don't even know where it was made. Okay, here's the final assembly of this part before it's actually installed in the machine. So the pin goes down the center. Here's the 1/4 20 set screw that will follow it behind, and it will hold it in place. And then the set screw is conically ended. This is an 1/8 inch hole, so it sets in that. And I wish I'd done a little bit better job of reaming. I should have gotten a different reamer. I think the other one's bent. And it precessed, so it made the hole a little bit larger. There is a tiny bit of wiggle here, more than I would have liked. But when I tighten this down, that should stop this from moving at all, because it'll press the conical end in tight, and the other end will be on the set screw. So that should be all right. So we're done here, and we just move on to the aluminum part next, which has got a ton of parts, pieces.